Hi folks, this is a video on the introduction to chapter 8, section 8.1 in our notes on right triangle trig and applications. It starts on page 136 in your notes. So if you pull out page 136, you can follow along with this video. You can take your notes, pause anytime you need to, and you can follow along here. So we have been studying trig since early on in the semester. Chapters 6 and 7 were about trig. Those chapters we took an approach that's known as the unit circle approach to trig. So we approach trig by looking at the unit circle, defining sine and cosine in terms of points on the unit circle. We're going to switch gears a little bit here. Chapter 8 is also about trig, and we'll be able to study a lot of applications in this chapter and then in this section. But this is an approach called right triangle trig. So we're going to approach trig from a triangle perspective. Our goal in this section is to do what's called solve right triangles. And we'll see as we go through the notes what that means. This first page is just a lot of sort of definitions, setup, remembering some things about triangles. Remember that the opposite side from the right angle in a right triangle is called the hypotenuse. So in section 8.1, we're studying special triangles, just right triangles right now. So the angle, there's a right angle in your triangle. The side opposite that angle is called the hypotenuse. Labeling is really important here. When we talk about trig and triangles, we are always going to label a right triangle so that side A, little a, is opposite angle, capital A. Side little b is opposite angle, capital B. And side C is the hypotenuse. Now it doesn't matter in this case, side A is down horizontal at the bottom, but it doesn't matter if that's the case or if side A was here. So if side A was this vertical side, that's fine, but the angle opposite is angle capital A. And so we're going to take this right triangle with these labelings and we're going to define the right triangle definitions of the trig functions for an acute angle, theta. That word acute is important. Remember that that word acute means less than 90 degrees. And the idea here is that the values of each of the 6 trig functions of an acute angle are ratios of the lengths of the sides of a right triangle. Now you may have heard of SOHCAHTOA. If you have, great. If you haven't, that's okay. I'll explain it here. SOHCAHTOA is a mnemonic device. It's a device for remembering these definitions. So the definition of the sine of angle theta, so take a peek at this picture here on the right. Theta is this angle down here. The sine of theta is the length of the side opposite divided by the hypotenuse. So sine of theta is opposite over hypotenuse. So here you can see where I meant that to be a highlighter, where SOH comes from in SOHCAHTOA. Sine is opposite over hypotenuse. The cosine function is defined as the length of the side adjacent, so right next to theta. In this case, that's labeled side A, divided by the hypotenuse, which in this case is labeled side C. Right? So cosine of theta is adjacent over hypotenuse, A over H, CAH. That's where this mnemonic device comes in. And then the tangent of theta is the length of the side opposite theta over the length of the side adjacent to theta. So it's opposite over adjacent. Now, if you know those three things, then you can use the definitions of secant, cosecant, and cotangent that we already know. So for example, tangent of theta is opposite over adjacent, which means that cotangent of theta is the reciprocal, adjacent over opposite, right? If you know the three basic trig functions here, sine, cosine, and tangent, then all you have to do is use their reciprocals to define the other three. So off to the side, let's define the other three trig functions. So let's define cosecant of theta. If sine of theta is opposite over hypotenuse, cosecant is its reciprocal. So that's hypotenuse over opposite. Cosine of theta is adjacent over hypotenuse. So it's reciprocal secant. Secant is the reciprocal of cosine. That's hypotenuse over adjacent. And again, I'm just abbreviating here, hypotenuse and opposite and adjacent. And we already wrote it down, but to have it here off to the side too, cotangent of theta is the reciprocal of tangent. Tangent is opposite over adjacent. So cotangent is adjacent over opposite. Okay, let's go on to page 137 and try example 1. On page 137, example 1 says, given the triangle, find the value of each of the 6 trig functions of the angle theta. Make sure all fractions are simplified and all denominators are rationalized. So here we have a right triangle. We have 2 sides given, and our angle theta here is in the lower left-hand corner. This is the angle we're trying to find all of the trig values of. So sine of this angle theta, cosine of this angle theta. We saw on the last page that the 6 trig functions are defined in terms of ratios of the side lengths of the right triangles. So in order to answer this question, we need all 3 sides. We don't have C yet, the hypotenuse, but we can find that because this is a special triangle, right? We have a right triangle. And anytime you have a right triangle, you can use the Pythagorean theorem if you have 2 sides and you're missing any one side. So remember that the Pythagorean theorem, and this is why labeling is so important, the Pythagorean theorem says if you have a right triangle, its legs are labeled A and B and its hypotenuse is C. Now it doesn't matter which one of these legs is A and which one is B, but the hypotenuse has to be C. Pythagorean theorem says a squared plus b squared equals c squared. So we have 5 squared plus 12 squared is c squared. So we have 25 plus 144 is c squared. So c squared is 169, and that is a perfect square root, and that's the square of 13, so c is 13. So in your diagram, you can put that in now. Now that you know your third side, that c is 13, you can use the definitions from the last page and flip back if you need to. So our job is to find the value of each of the 6 trig functions. So that means we're looking for sine of theta, cosine of theta, tangent of theta. So let's start here. So sine of theta is opposite over a hypotenuse. So this is a definition that you have to know, that you'll come to learn as you practice. Opposite of angle theta is 5, hypotenuse is 13. So the sine of theta is the number 5 over 13. Right? It's realistic. We know that the sine of an angle has to be less than 1, has to be, or between -1 and 1. So this is certainly reasonable. The cosine of theta, C-S-O-H, SOHCAHTOA, if you need to write it up top to help. Again, it's just a memory device. C-A-H-T-O-A. C-A-H, cosine of theta, is adjacent over hypotenuse. Adjacent to angle theta is the side 12 over hypotenuse is 13. And then tangent of theta, sure, you could do sine over cosine and do your fraction work, that would work too, but it's also defined as opposite over adjacent. So opposite is 5 and adjacent is 12. Now, those are the first 3 trig functions. We still have 3 others to find, but if you have sine, then to find cosecant, that's just its reciprocal. So cosecant of theta is the reciprocal of sine, so that's 13/5, right? Just flip it over. That's all reciprocal means. Secant is the reciprocal of cosine, so that's 13 over 12. And cotangent of theta is the reciprocal of tangent, so that's 12 over 5. So we've answered the question. We found sine, cosine, tangent, cosecant, secant, and cotangent. We found the 6 trig functions of this triangle. So sometimes we're tasked with the last example, finding the 6 trig functions, and most of our problems are actually going to say this, solving a right triangle. So to solve a right triangle, or any triangle, means to find the missing lengths of its sides and the measurements of its angles. So you're going to be given some side and angle information. You have to fill out all of the rest. Setup is really important here. So we're going to solve the right triangle. It says angle A is 30 degrees and side C, which we know is the hypotenuse, is 12. So setup is really important. So first I'm going to draw a right triangle. So draw yourself a right triangle. Sorry for the squiggly hypotenuse, that's just what my stylus on the iPad does automatically when I don't have a horizontal or a vertical line. Okay, so we know that the hypotenuse C is 12. That's opposite the right angle. Angle A, you can pick either one of your angles to be angle A. So I'll use the one at the bottom right. I'll call that angle A. That's 30 degrees. Now the key is if I label that angle A, then the side opposite it has to be little a. And then the other angle is capital B, which means the side opposite it is little b. Okay, so we have to find the missing angle and then the missing sides. So the angle's pretty straightforward. The sum of the angles in a triangle is 180 degrees, right? So angle B is 180 minus the 90-degree angle minus the 30-degree angle. So angle B is 60 degrees. So let me just box this because it's part of our answer. Okay, so now on to finding some missing side lengths. We can't use the Pythagorean theorem right now because we only have one side length. We can only use that if we have two. So let's look at what we have. we have angle A, and we want side A, right? So let me make a note of this. We have angle A. We need to find side little a. So for side little a, that's the opposite side from angle A, and we know the hypotenuse. So if we want opposite and we have hypotenuse, which trig function connects opposite and hypotenuse? The sine function, right? So sine of angle A is opposite over hypotenuse. So figuring out which trig function to use is all about what information you have, but also what information you are trying to find. So A is 30 degrees. So the sine of 30 degrees is opposite, which is little a, over hypotenuse, which is 12. Well, the sine of 30 degrees is 1/2 equals a over 12. So side A has length this, 6. So we were looking for side length A. We knew that was opposite angle A, and we also had hypotenuse, so we could use the sine function. Okay, so the last thing that we need to do is find side B. There's a couple of different ways you can do that. Now that you have two sides of the right triangle, you could certainly use the Pythagorean theorem to find the third. But you could also use one of the trig functions, and so I'm going to show you that way. Pythagorean theorem is something you've seen before, so I want to show you how you can use one of the trig functions. So we need angle B. We have angle A, we also have angle B, so you could use either one. But one of the things that we could use is we could use the cosine function with angle A. So let me write over here, cosine of A is adjacent over hypotenuse, right? That's the right triangle trig definition of cosine. Well, adjacent to angle A is side B, that's what we're looking for. We have the hypotenuse. So the cosine of 30 degrees is adjacent, which is little b, over hypotenuse, which is 12. Cosine of 30 degrees is root 3 over 2 equals b over 12. And if you multiply both sides by 12, those 12 and the 2 reduce, and you get that b is 6 square roots of 3. So if you found b using one of the other trig functions, or if you found b using the Pythagorean theorem after you have side A and side C, that's fine. You're going to get 6 square roots of 3 no matter what, as long as you simplify. I'd like you to pause the video, and on example 3, I'd like you to set up the triangle and at least find the third side. And then you can play the video back and we'll go over how to find the missing angles as well. The angles are a little bit tricky, a little bit different than what we saw in example 2, but I think it's good practice to set up the triangle. Okay, so when you set up your triangle, you might have your A and B in different spots than I do, and that's okay. The key is that angle B is across from side B, angle A is across from side A. When you use the Pythagorean theorem to find the missing side, you get that the missing side B is 2 root 2. It's a square root of 8, but then simplify that before we use it. So now we're missing angle A and angle B. So let's work on next finding angle A. So for angle A, I know that I've got all three of my sides, so really I could use any of the trig functions because I have all three sides, adjacent, opposite, and hypotenuse to angle A. So really it doesn't matter which one you use here. I can say that the sine, if I use the sine function, the sine of A is opposite over hypotenuse. Which is 1 over 3. So you have that the sine of A is 1/3. Well, we don't want the sine of A, we want angle A, and this is where the directions say leave your answers in terms of trigonometric functions. If the sine of A is 1/3, then A, this is back to chapter 7, is the inverse sine of 1/3. So it's an inverse trig function. Okay, if you do it on a calculator, just so you can have a sense of it, you get about 19.5 degrees. But we're going to be leaving our answers without calculators in terms of trig functions. If you decided to use cosine as adjacent over hypotenuse, you would get a different inverse function, but if you plugged it into a calculator, you get the same value. So now all we have to do left is find angle B. So similarly, in this case, you can use any of the trig functions. I tend to use sine when I can use any of them just because it's the first one in SOHCAHTOA, but you can use any of them. So sine of B is opposite B, right, over hypotenuse. So for angle B, sine of B is opposite over hypotenuse. Opposite is side B, which is 2√2. Hypotenuse, 2√2. And hypotenuse is 3. So we have that the sine of angle B is 2√2 over 3. So that means that B is the inverse sine of 2√2 over 3. Again, if you plugged it into a calculator, you get about 70.5 degrees. But we're going to be leaving these as trig functions. And kind of just as a quick check, 19.5 plus 70.5, right, plus our 90 degrees. We always want to make sure that it makes sense in terms of the sum of the triangle, the angles in the triangle being 180. So here's an example where if it depends on what information you've started with, that sort of dictates what the process and what the your final answers look like. So that's really all the content of this section. So if you feel like you're not sure of any of those pieces, just go back and watch pieces of the video before continuing. The rest of the section is on applications, so on word problems involving trig. So if we go to page 139, there's an important set of definitions at the top that will help us set up some problems. They're angle of elevation and angle of depression. If a person is looking up, if you're standing and you're looking up at an object, the acute angle measured from the horizontal to a line of sight to the object is called the angle of elevation. If the object is below the horizontal, your line of sight, the angle between the line of sight and the horizontal is called the angle of depression. So let's take a look at an example together. Example 4, a plane rises from takeoff and flies at an angle of elevation of 30 degrees with the runway. When it is at a height of 500 feet, find the distance the plane has flown. Okay, so I'm going to sort of draw this out. So here is sort of my plane sitting on the ground just before takeoff. Here's my runway. So my plane rises from takeoff at an angle of elevation of 30 degrees with the runway. When the plane is at a height of 500 feet, height is measured perpendicular to the ground, right? So here we have 500 feet. Find the distance the plane has flown. So if you look at our picture, right, my squiggly hypotenuse here, that's how far the plane has flown. That's what we're looking for. So if you want in a problem like this, you can call it X or you can call it C, kind of whatever you want. So let me write a couple of notes on the side. So in the picture, X is the distance flown. The only information that we have here, well, we have the bottom left angle, which is 30 degrees. So we want to relate opposite, right? Opposite 30 degrees is the 500 feet we know, and we want hypotenuse. We need to relate opposite and a hypotenuse of the 30-degree angle, right? Because you have that 500 feet. So if we want to relate opposite and hypotenuse, we can use the sine function again. So sine of 30 degrees equals opposite over hypotenuse, which is 500 over x. Sine of 30 degrees is 1/2 equals 500 over x. So that means that x is 1,000. So to answer the question, the plane has flown 1,000 feet. Right, so in these applications, the setup is very similar to the other examples that we looked at, except we don't necessarily have to solve the entire triangle, and we don't necessarily have all the information to do that. We have to work with what information we have and figure out the side or the angle that we're looking for. Okay, I'm going to have you pause the video and try example 5. It's a similar type of application. So try example 5. I will do it out and then you can replay the video to see the solution. If you had trouble with the setup at all on this one, I put the little guy, this is where he's laying down on the ground, right? He holds the string at ground level. The kite is at a height of 30 feet. So if the kite is 30 feet in the air, that's measured perpendicularly. And 65 feet of string is left out. So here's his string, right? Find his string. We're looking for that angle of elevation with the ground. I've marked it theta here. We need the angle theta. We know the opposite side and we know the hypotenuse, so we can use the sine function. Now, if you wanted to, you could use the Pythagorean theorem, find the third side, and then use any of the 6 trig functions that you wanted, but that's a lot of work to find that third side, especially without a calculator. Those numbers are going to get decently big. So just work with what you have. So sine of theta is opposite, which is 30, over hypotenuse, which is 65, which reduces to 6 over 13. So theta is the inverse sine of 6 over 13 degrees. So for us, this is how we're leaving our answer in terms of a trig function. Just to put it into perspective, It's about 27.5 degrees. You can do that on a calculator if you're trying to sort of put it into perspective, or of course if my math lab asks you. Okay, what I would like you guys to do before class on Monday is to try example 6 and then example 7, just 2 more applications of the right triangle definitions of trig. You can always go back, rewatch parts of the video if you need to, and then try your homework. We will go over example 6 and 7 as sort of warm-ups and wrap-ups in class next time we meet. Thanks for watching.